And then we have our new example, that is, find the area bounded by the curve y is equal to x squared minus 2x plus 3 and lines x equal to y and y is equal to 4. Again, the first thing we do here is, of course, to plot our equations in the Cartesian plane. But we need to compute first the coordinate of the vertex of our parabolic curve y is equal to x squared minus 2x plus 3. Now, we know that this form is the same as with our general equation of parabola, which is x minus h squared is equal to 4a, that is in positive or negative, y minus k. However, how are we going to change this into this form? As we know that it has a variable x here, which is in the first degree. So again, you can use differentiation or just letting our y prime is equal to 0 to get the maximum point or the minimum point, or you can use the basic concept in geometry. But let's try to solve using both method. So you can actually use this one by completing the square. So we can rearrange this equation as x squared minus 2x is equal to y minus 3. So in order to complete this and to convert this into a square of binomial, like this one, this is square of binomial. So we introduce a constant that would complete the square or the square of binomial. So in this case, we know that it's negative 2. So we have to divide 2 here by 2. The result would be 1, negative 1. Then square negative 1, which give us 1. So therefore, you add here 1. Since upon introducing a constant 1 in our equation, so the value of our equation has changed. So therefore, we introduce the same number but opposite in sign. So therefore, we should have a negative 1, and then transposing it to the right side, then we have here plus 1. So therefore, if you add 1 and the negative 1, so since if we transpose positive 1 to the left, you would have negative 1 here. So therefore, plus 1 minus 1, that give us 0. So therefore, our equation remains the same, as if that we are adding 0 in the equation. Or so we can now factor this as square of binomial. We can have x minus 1 squared. And then, on the right side, we have y minus 2. So we have now satisfied this general form of parabola in which this is a positive equation. Thus, it is opening upward. Okay? Since we have our x here that is raised to the 2. So we have our value of h here is equal to 1 and the value of k is equal to positive 2. Okay? So this is the coordinates of our vertex. Now let's try to solve it by maxima and minima. We have to get the first derivative of y and let that be equal to 0. So we have y prime is equal to the derivative of this equation. We have 2x minus 2. And y prime is equal to 0, then we have 2x minus 2. Then 2x is equal to 2, x is equal to 1. So this is our h, or the x coordinate of our vertex. Now to compute for y coordinate, just substitute the value of x in our equation. Then we have y is equal to 1 squared minus 2 times 1 plus 3. Using this equation here, so we have y is equal to 2. So this is our k. Okay, so you can use either of the two, whichever is easier for you. So since we have already our vertex, and we can now plot this equation in our Cartesian. Now we know that this equation is parabolic, which is opening upward, since again we have positive equation here, this is positive, and we have our vertex which is in the coordinates 1, 2, so we have 1, 2 here, so at this point. And then from the given, we have the lines x equal to 1 and y is equal to 4. Now, if we draw x equal to 1, it is just vertical line, and y is equal to 4, this is just a horizontal line. So when we have x is equal to 1, we have on this line x is equal to 1 and y is equal to 4. We have this one, y is equal to 4. And then our parabolic curve, which is opening upward, then we have this one, which has an equation y is equal to x squared minus 2x plus 3. Now we know that there are point of intersections between the lines and our parabolic curve. So the point of intersection is at this point, okay, and this point here and this point, the left side. So again, we need to compute the point of intersection so that we know the limit of our integration. But since we have the area that is bounded by x equal to 1, y is equal to 4, and this curve, therefore the region that we will be computing here is this one. So our next goal here is to compute for the point of intersection. So the location of this point, the coordinate at this point, and the coordinate of this one. Also, we have and this point of intersection here. So we will not be computing this point of intersection at this point, since our area is only at this point here. So our area is bounded by these three intersections. So how are we going to compute for the point of intersection? By just letting here, at this point, we know that our y is equal to 4, correct? Our y is equal to 4. So let's just have to compute for the value of x. So we can use the equation of our parabola, that is this one, y is equal to x squared minus 2x plus 3. We know that our y is 4. So we could have x squared minus 2x plus 3. So we have x squared minus 2x minus 1 is equal to 0. You can try any method in the algebra. You can use quadratic equation. That is, we have x is equal to negative b plus minus square root of b squared minus 4ac over 2a. Okay, so you can compute for the two values of our x by first letting this as positive, then the second one letting this as negative. Or you can use completing the square to this one. Or the easiest way, of course, if you have your calculator, then you can use quadratic equation in your calculator to compute for our value of x. If we use this equation, this quadratic formula, then we set our a here, that is the coefficient of our x squared. We have 1. Our b is negative 2. Our c is negative 1. From our general form of quadratic, that is a squared plus bx plus c is equal to 0. So if you try to substitute all this value in our formula, we have negative b, that is negative times negative 2. Let's start first with plus square root of, we have negative 2 squared minus 4, our a is 1, our c is negative 1, over 2 times 1, we have x is equal to 2.414. Okay? Now, if we have negative, we have our x here, that is negative 0.414. Okay? So these are the two values of x now for this equation. Or you can just use your calculator. So if you have your Casio calculator, just click a mode, then number 5, the equation, then number 3. Okay, since you have quadratic equation, ax squared plus bx plus is equal to 0. Then just encode the coefficients of this equation. We have a is 1, b is negative 2, and c is negative 1. Correct? And then you have the value 1 plus square root of 2, that is 2.414, and then the second value of x, which is negative 0.414. So you have, at this point, when your y is equal to 4, your x is equal to 2.414. Now, the location of negative 0.414 is on the left side. So at this point of intersection here, we have y is equal to 4, x is 0.414. That is the coordinates. So the coordinate is 2.4144. How about the intersection at this point? Now, at this point of intersection, again, this is just the vertex of our curve, which our x is 1 and our y is 2. That is the coordinate of the point of intersection at this point, in which our x at that point is 1. That is the line, this vertical line here, which is x is equal to 1. Or you can just use this equation again. We have y is equal to x squared minus 2x plus 3. Then we know that our x is 1. So we substitute the value of x. Then we have our y here, which is equal to 2. Now, how about at this point of intersection? At this point, we have the point of intersection of our two lines. So therefore, this coordinate here is when our x equal to 1, our y is 4. Now, after computing for the point of intersections, I opt to redraw the curves in scale. Okay? So again, the point of intersection is at this point, 2.4144. That's the intersection of the line y is equal to 4 and the curve. And we have the point of intersection of the line x equal to 1 and the curve, that is 1, 2, which also happens as the vertex of our curve. And then the point of intersection of our line y is equal to 4 and the curve at the left side of the coordinate system, that is this one. So we can now compute for the area of the shaded region, which is bounded by the line x equal to 1, y is equal to 4, and this curve. But first, we have to create a vertical strip. Now, this vertical strip and the area of that vertical strip is equal to, now, the area of a rectangle, that is the length times the width. Now, in this case, our length is the y, and in the width, that is the derivative of x. This is derivative of x since x here is infinitely small and it is changing. So therefore, our area here is equal to the integration of y dx. And our limit, now our x here, or the derivative of x, is changing from this point up to this point here. And thus, we only have the limitation of our vertical strip, that is from when our x is equal to 1 to x is equal to 2.414. So this is the limit of our strip. Okay, our x is changing from 1 to 2.414. So we have 1 to 2.414 as our limit. But looking at our y here, our y is floating. Our length here does not lies on the x-axis. But we know that if we plot our curve and our line, we always refer from the x-axis. Like for example, if we try to plot this curve, we always goes from the x-axis. Okay, let's say that's our y sub 1. And the same as with this line, okay? Let's say that's our y sub 2. We always refers from the x-axis when we're trying to plot the y-coordinate of our curve or of our line. So therefore, we can say that our y here is just the difference of y sub 2 and y sub 1, correct? Unless if our y is in this position, like for example, this one, okay, if this is our vertical strip and this is our y, so we can say that our y here is the equation of the curve. But in that case that our y is floating above our x-axis, like for example, this one, if we try to create a vertical strip, so our equation here, let's say that's our y, so our y here is equal to this one. Let's say that's our y sub 2 and it's our y sub 1. So therefore, our y is always equal to y sub 2 minus y sub 1. Since again, we always refer our y from the x-axis. So therefore, again, our y here is equal to y sub 2 minus y sub 1. So we have our area is equal to y sub 2 minus y sub 1 derivative of x, and the limit is from 1 to 2.414. Now, since again, we are integrating it to respect to x, so we need to change this y variable to a function of x. Now, our y sub 2 here, take note, our y sub 2 touches the line. Y is equal to 4, correct? So therefore, our y sub 2 is equal to 4. So we have y sub 2 is 4. Minus our y sub 1 here, as what you can see here, our y sub 1 touches the curve. So therefore, we are going to use the equation of the curve, and we know that our y of the curve is equal to x squared minus 2x plus 3. So we have, don't forget the parentheses, since we have negative outside, we have x squared minus 2x plus 3. And this is an derivative of x. Now, limit is from 1 to 2.414. By further simplifying, we have 4 minus x squared plus 2x minus 3. That's the derivative of x. So we have the area is equal to the integration of negative x squared plus 2x. We can combine 4 and 3. Then 4 minus 3, we have plus 1. And that is dx. So we have limit from 1 to 2.414. Then we have to integrate them individually. We have a is equal to negative x cubed over 3 plus x squared plus x. And the limit is from 1 to 2.414. We have our area here, which is equal to 1.886 square units. So the area of this region here is equal to 1.886 square units. And this is our answer. And that ends our discussion in areas using integration. So if you have questions, you can comment it down. And then for more videos, don't forget to like and subscribe. Thank you again for listening, and see you in the next video.